Hello class, George here, and we're picking up right where we left off in terms of dealing with surface views and basically creating a very simple game engine that we're going to be using from here on out. Now, hopefully, if you haven't already, you've gone through and watched the prior video if you needed to. Possible you followed along in class, in which case this is the first video with new material that you'll need to watch through. I will be coding everything out in Android Studio. I am using Android Studio 3.0. Feel free to upgrade along with me if you want to, or continue to use the earlier version. Anyway, the last thing we dealt with was we had drawn to our screen and we had displayed it on the emulator. However, at present we have no way of controlling our frame rate. We will look at a better way of controlling our frame rate later on. For right now, we're going to use, well, a very simple method of doing that. Now, why do we need to control our frame rate? Well, for one thing, it's going to be variable. We don't necessarily know how long it's going to take one frame versus another frame to render out, based upon other system things. Maybe a garbage collection happens, something else. It could be 16 milliseconds, maybe it's 30, maybe it's even longer than that. And if we're running a game or a physics simulation or something else like that, we need to know how much time passes between each update of our game, so that we can use those in our calculations for things like acceleration and velocity, or even changing the animations maybe on an image or a bitmap. So for the moment, our game is rendering as quickly as possible. If we want a cheap way to reduce how much rendering it's actually doing, we can put our thread to sleep for a short period of time. So here we have a private static final integer value, which is called our desired frames per second, which we're going to set to 30 in this case, and that's a respectable number for a mobile platform. We're also going to store in that private static final int time between frames, which is going to equal 1,000, because we're dealing with milliseconds, divided by that desired frame rate. What we're going to attempt to do is put our thread to sleep, which is pretty much just like, well, putting something to sleep. It just halts progress for that particular amount of time until a certain duration is passed. In that case, our time between frames. And of course, it's a try-catch block, so I need to make sure we handle that. So why don't we go ahead into our game view and begin adding what we need. So we're going to do this inside of our run loop. So after we update and draw, we're going to go ahead and pause things for a short period of time. But first we need to create those different values to hold. So let's do a private static final int and desired, let's just say FPS is equal to 30. You can set this higher or lower, it's up to you. You're not guaranteed to get it. Then we have our private static final int and time between frames is going to be equal to 1,000 divided by our FPS. All right? Now it's possible we'll take longer time than that. It just depends. Now we just need to do our try loop. So after our draw phase, we're going to do a try. And we're going to do our game thread.sleep. We're going to pass in our time between frames. And we're going to put in our catch block. And that's just going to do an interrupted exception, E, and we'll just end it off right there. Great. So that's a way for us to slow things down and to make it a little bit closer to what we would expect. Now we still need to record the time between each of our updates. So what we want to do here is in our game view, for our run method, we're going to update a value called previous time and current time in milliseconds. We're going to subtract those two from one another, and that'll give us a value called delta time, which is the amount of time that's transpired between each one of those updates, which is the real value we're after. So why don't we go ahead and declare these two values. Now in this case, I'm creating them inside of run. However, this is going to, of course, prompt garbage collection to occur, because these values will be created and then destroyed once this function's done, and this function will be called many, many times. So I'm going to go ahead and move that up to the top and store that away. So bringing this over here and going up here, let's do a private long and call this previous time milliseconds. And let's do a private long and current time in milliseconds. Great. Now within our run method is where we need to grab the previous time. and work with that. So here's run. Now we do need a value, a default value at some point. Otherwise we would have, potentially two zeroed out values, and then our time would be 0. And if we divided anything by time, then we'd get a big error. So what we are going to do here is make sure that when we first start things off, we're going to go ahead and seed our previous time, milliseconds, is equal to system dot current time in milliseconds. Now that we have that value seeded, we can go ahead and really set things up for how they're going to work. So in our while playing, we're going to do a current time in milliseconds is equal to, once again, system dot current time in milliseconds. And between that line, the while loop, and that one being called, we should have a tiny bit of change at least occur. Next up, we're going to create our delta time value. Now, delta time, I'm going to make something special. I'm going to, for now, make this a public static float value and call this delta time. Hopefully you'll see why I'm going to do that in just a second. Now this is going to be in seconds, so make sure you understand that. It will not be inside of milliseconds. So let's calculate that. Once we have our current time, we're going to do delta time is going to be equal to our current time minus our previous time divided by 1,000 milliseconds. Make sure that's a value 0.0f. Great. So now we have delta time in seconds that we can work with later on. So now that that's done, after we've finished everything, we're going to go ahead and store our time between each frame. So let's go ahead and do a previous time is equal to our current time in milliseconds. So what's happening here is all of this time has passed. We're recording it here, and when we come back, we're going to grab the new time. And then we're going to subtract those two to determine how much time has transpired, and then we can use that information anywhere we want to. And since we're storing this in a public static variable, we'll be able to use the class GameView to access it by calling GameView.time or .delta time and working with that value however we pretty much see fit. Now the next thing we want to deal with is our canvas, specifically the screen resolution. Now we're not going to address this just yet. It's going to be something we're going to look at in a following lecture. But for right now, we're going to go ahead and take a look at how we can grab the screen resolution and use it to our advantage. So here, within our game activity, we can go ahead and query the window manager to grab the display that we're working on. We can then use a point object, which is just going to hold an X and a Y value, and use the display.getSize by passing in the point to gain the information we need about our object. We're going to pass this into our GameView constructor, and then we're going to set that up as a static value. The idea is just like delta time, many of the other objects in our scene are probably going to need this value, so why not supply it in an easy-to-use static area that any class can grab. Jumping over into our main activity, let's make that a lot larger, and let's go ahead and after onCreate, why don't we go ahead and do a display. Display is going to be equal to a getWindowManager dot getDefault. Whoops, hold on a second. Let's Alt-Enter that in. There we are. So let's do dot get default, whoops, get window manager dot get default display. There we are. So there we've grabbed our default display from our window manager. Now we'll declare a point. Point is equal to a new point object. We're going to pass this in and get our display information. Now we're going to pass this into the constructor here. But we haven't done that yet, so we're going to get an error, but we're going to go ahead and pass in our point. Point, singular. All right, so going back to our game view, let's update our constructor to deal with this. So go ahead and do a point, Alt-Enter, and let's go ahead and create a variable, point screen size. It's going to be equal to nothing at the moment. Inside of here, we're going to set screen size equal to point. All right? Now, it's perfectly fine to go ahead and store it this way, but a more convenient method is to make something, like I said before, public and static. And specifically, I'm going to use the name screen width and screen height. So let's go ahead and do public static int screen height and public static int screen underscore width. All right, and we're going to fill these up inside of here. So height is equal to point.y. There we are. And screen underscore width is going to be equal to point.x. Now, there is a problem with doing it this way, and that is because it's public, it's possible for external entities to mess with this value. So why don't we go ahead and change this a little bit and make it private and create a getter and a setter. So go ahead and hit Alt Insert, and let's go ahead and just do a getter because we don't want anyone else to set this value. And we'll go for screen height and screen width and hit OK. And now we have our public static integer values that are going to return to any outside entity this information as necessary. Now we're about to get to the really fun stuff, and that is when we get to work with a GameObject class. So if we've looked at kind of things so far, we haven't really come up with any sort of a system to easily render things. Now we do of course have our draw loop and inside of, our update and draw methods inside of our run function. And that's going to be sort of the core and element that holds everything together. That is, our game objects are also going to have update methods and draw methods. And it's going to be the responsibility of every game object we have to make sure it has a draw and an update method, even if they're empty. The idea here is we're going to create an abstract class, and any game object will inherit from that abstract class, and that then guarantees they will have a draw and an update method, and if they don't, well, it's not going to work. As we get further in this, what we're going to end up having is a list of all the different game objects in our scene. We can add to this list, we can subtract from this list. It's based upon what we're doing in our particular game. So let's say enemies are being spawned. Well, then that list gets larger. Or maybe enemies are being destroyed and the list gets smaller. Either way, all these different game objects share one particular thing, and that is they all have an update and they all have a draw method. During update, we iterate through every single one of those elements and make sure we call their update method. Each one of them update a little bit on the screen, and then we move on. Now we draw all those different objects, and hopefully they would have updated somewhat, and now when we draw them back to the screen, they look like they're in a slightly different position. And that's how we're going to create our entire game engine for right now. We're going to make this a little bit more advanced as time goes on, because we haven't talked about anything like cameras or views or world coordinates or anything like that that would we normally get into very early if we were dealing with 3D geometry and OpenGL or DirectX. But we'll get to that. So let's go ahead and define our public game object class. It's going to be a public abstract class, and inside of that, we're going to have a method for start. This could either be called start or init. I'm actually thinking I'm going to change that to init instead. Then we have public abstract void on update and then on draw. On draw is going to take in a canvas object. Remember, we're going to get that canvas object. We're going to lock down that canvas actually, and then we're going to pass it to each one of these different objects. And that object is going to be responsible for drawing everything about itself to that canvas. Let's go ahead and create this. So coming over here to app, Java, and our particular class, let's right click new Java class, and let's call this game object. There's no superclass for us or interfaces that we need to deal with. However, it will be abstract, so you might as well go ahead and select that. Hit OK, and this is what we end up with. So let's create those three methods that we need that are going to be the basis for everything in our game engine. That's going to be a public abstract void init, so it doesn't take anything. Now we're going to do a public abstract void and on update. Now notice that they're using that the abstract keyword is in there and that we have a semicolon on the end and there's absolutely no code in it. Remember, this is an abstract class. These abstract methods we are expecting someone who's using this to fill that information in. So let's do public abstract void and on draw, and then we're going to work with a canvas. Great. I'll enter to bring that in, and that's pretty much it for the base class of our game object here. So what we're about to do now is we're going to create that list of game objects I was speaking about before. This is going to stay within our game view object, and then we're going to iterate over that entire list, as we can see here in update, and make sure we call that onUpdate method. We're also going to do the exact same thing for the draw method. In the draw method, we grab our surface, check if it's valid, lock it down, we clear out the entire thing, and then we're going to iterate over every single one of our objects and draw them out. And then finally, we unlock that canvas and we post the information. So jumping back into our game view, let's go ahead and start this up. We're going to need to create that list, so let's define a variable for it. So let's do a private list, and we're going to hold in that a game object, and we're going to call this game objects. All right? And that is going to be equal to, a new array list of type game object. Now that we've created our list of game objects, what we need to do now is make sure we iterate over that list and provide the update method and the draw method for each. Now at the moment we haven't created any game objects, so there's really nothing to iterate over, it's just an empty list. We'll be dealing with populating that a little bit later when we get into specific kinds of game objects you might want to have for your game. So jumping down into update, let's go ahead and create our for loop. So for int I is equal to 0, I is less than game objects dot size, and then I++. And actually, you know what I'm going to do? I'm probably going to make I a member of the class itself. So let's do that and declare it at the top. This way, we're not creating the integer I repeatedly over and over again. We can reuse this whenever we want to. And we're going to do that in here. So now I is equal to 0 for initialization. We check its size, and then we continue on from there. Now we're just going to go over game objects dot get I, and then dot on update. And we're going to pretty much do the same thing for drawing. Let's grab the exact same code, go into draw, and after our surface draw right here where we clear out the canvas, we're going to paste the same bit of code, and instead of on update, it's going to be dot on draw. Now we need to put that canvas object in, and there it is. Pretty simple. We're now going to create a series of different game objects that we're going to work with to give good examples of how you can create sophisticated elements that you would want in a game. However, most of these are going to rely upon a class such as Vector2, which is going to allow you to have an X and a Y coordinate, or maybe even a Z if you want. But really what it does is simplifies addition and subtraction, multiplication, things like dot product, cross product, and so forth, so that you can easily make these calculations and move on. Why don't we go ahead and create a Vector2 class in this video, and then you can follow along so that you can work with this vector class in the future. So let's go ahead and right-click, go to New Java Class, and name this Vector2. And that's all we need to do. All right. Now we just need to figure out all the different things that a Vector2 has. So one thing is I'm not going to work with getters and setters for these objects because I want to be able to access these elements and not have any overhead of calling functions and so forth. So we're just going to do a public float x and a public float y value. Now if you want to, you can consider adding a z term and making this a Vector3. Or if you want to, you could even add an integer term, and that integer term would be a different layer that it is in the background. And you could sort things based upon what layer it's on. So you could have foreground and background elements. We're not going to deal with that right now in this case. We're just going to create a standard Vector2 class. So let's go ahead and create our methods here. We're going to want a few different ones. We're going to want addition. Let's just write them all out. Addition, subtraction. We're going to want scalar multiply. We're going to probably want, let's see, the dot product. And we're also going to want, let's see, in this particular case, we don't really have a cross product. A cross product would be come out. It would be a vector coming out into the third dimension. So that doesn't really make any sense for us. We might want to support things, though, like division, just to make our life easier. And that should be about it. So why don't we go ahead and make these methods happen. So let's go ahead and do a public. And here's where we got to think about how we want to implement these things. Do we want to return a new vector, or do we want this to impact the vector we're actually working on? And that's going to change how we implement these methods. For instance, we could make static versions of these methods that would take in two operators, a Vector1 and a Vector2, and it would then return to you a new vector that you'd operate on. Or we could create non-static methods, and the idea is that the vector you're operating on is what's going to end up being changed. And in one case, you're going to end up making more variables than the other. So we got to be careful. For right now, all I'm going to do is I'm going to create a new vector2 that comes out of these operations. And if we want to change that in the future, we can. So let's do a public vector2, and let's just call this add. And it's going to take in another vector2 object. And let's just call that input. So addition's very easy. It's just going to be this.x plus input.x, and then it's going to be this.y plus input.y. And we're going to return a new vector3. So return a new vector3, or 2, excuse me. Now we don't have any constructors for this yet, so that's why it's giving us an error. So why don't we go ahead and create our first constructor. So Alt Insert, let's go ahead for constructor. We're going to want to include both terms, but we're going to want a few different constructors actually. So that's one constructor. We're probably going to want one that's empty as well. And the idea here is that we're just going to have it with 0 values, a 0 vector. So we're going to create a public static vector2 normalize method. And what this will do is it's going to take in a vector object. So let's do a vector2 vector, and it's going to normalize that vector the same way we just did using the Pythagorean theorem. So actually, instead, let's not have it return. Let's just have it do a void. So let's do vector.x times vector.x plus vector.y plus vector.y, and then we are going to go ahead and figure out the magnitude for this now. So we need to do square root, so we need to do math f dot math dot, we want to do square root. Now it takes a double, so let's see if we can do, no, that's not in there. So square root vector x blah 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 blah. So there we go. So it's going to be a float. Temp is equal to that. Well, let's keep it as a double for right now. That's just going to make our life easier. So there we are. Now we just need to divide our vector's components by that to normalize it. So let's go ahead and do vector.x is going to be equal to temp, excuse me, we could do divide equals, what is that? Temp. And then vector.y divide equals temp. All right, and that's it. So we've gone ahead and changed our values. All right, so there's been a tiny bit of a time jump since just a second ago. That's because I had to put my kids to bed. But anyway, let's get back to what we're doing here. So we already did normalize. Now we have this function called identity. That should actually probably be called, why don't we just do magnitude? Now I had this function called identity that I was creating, and I completely was thinking of the wrong thing. What I really want is public static float, and I'm going to do a magnitude. And what that's going to take in is a vector2 object, and all that's going to do is calculate the magnitude. So let's do vector2.x times vector2.x plus vector2.y plus times vector2, little vector dot y, and we're going to take the square root of that. So let's do math dot squirtle on that, and let's do double, or yeah, we'll do float or return. Let's see, what do we want to do? Yeah, return this value, and we're going to typecast that over to a float. There we are. Now, because we've done this, magnitude is actually the same as what gets created right here. So what we can do is with a normalized call magnitude. So why don't we do that instead? So we'll get rid of this part here and do magnitude, and then pass in vector. And then we'll divide both by that, and we'll get the result that we need. So now let's go back and finish up some things. So we had addition, which just added the different components and returned a new vector. Why don't we go ahead and do subtraction? And let's do minus and subtract. Next up we have scalar multiply, which is also somewhat similar. We're going to instead of a vector, we're going to do a float and scalar. And that's just going to multiply each component. So we're going to take this component, multiply it by that, and we're going to take that component and multiply it by that as well. And let's call this scalar multiply. Now let's do the dot product. If you remember properly, the dot product is the resultant of basically how much two vectors are in a line with one another. If they are perfectly parallel, it's a value of 1. If they're perpendicular, it's a value of 0. And if they're anti-parallel, it's a value of -1. So long, of course, that you're using unit vectors, that is vectors with a length of 1. So why don't we go ahead and create that? We'll do a public, and dot product returns a float value, a single value, and we'll do dot product. And let's take in 2 vectors for this. Or actually, no, it's this vector with another vector. So let's do vector2 and just say input. And let's go ahead and make this happen. So dot product's really easy. It's just going to be equal to each component multiplied by each other added to the others. So what do I mean by that? Well, it's going to be a return, and we're going to do this dot x times input dot x plus this dot y times input.y. And of course, if we had more components, we would do the same thing. So long as these values are unit values, that is unit vectors, this value is going to be a value between negative and +1. Otherwise, it's going to be scaled up based upon, the size, the magnitude of the object, the vector we're dealing with. Now, division's interesting. I mean, technically, division can always be done with multiply, so long as you divide by 1 over the number. But why don't we go ahead and create a division right now just to make our life easier. We're going to do division scalar, I guess. You know what? There's no real need to. I can always just do 1.0 divided by it. So that's add, subtract, multiply, and dot product. That's probably what we mainly need at the moment. If we need any other methods, we'll come back and deal with them as necessary. Yeah, why don't we keep that and move along? Now, I will say I did that entire Vector2 class off the top of my head from when I've done it before, so there's probably some mistakes I've made. We'll get to it later on when we test things out. But anyway, what we want to do now is dealing with drawing to the canvas. We're going to draw pixels. The reason I wanted to have the Vector2 object ready to go is because I'm going to be storing the points as Vector2 objects. So in this case, what we're going to do is canvas.drawPoint. So for every point we have, we're going to draw the float x, the float y, and we have a paint object. The paint object can dictate things such as the color and many other things that we'll be dealing with later on in this lecture. Now in this case, we're only going to be specifying a color for the paint object, but in other cases like lines and polygons and other things like that, you'll have a lot more options to work with. But we're not going to deal with that at the moment. So right now, what we're going to do is we need to define a new paint object. We're going to do that in our constructor once again to minimize garbage collection. We're going to only need one paint object. We don't need to continually regenerate or recreate this over and over again. And that paint object is going to be used later on for things like setting the color or setting, actually in this case, only setting the color. So here we have the hexadecimal representation with double F's being 255, which is our alpha value, followed by zeros for red, double F for green, and then 2 more zeros, or we can use the color.red value instead. And there are quite a few different colors you can use if you're not familiar with how to create hexadecimal values for things. But if you're an HTML guy, you've probably dealt with these kind of values before. Okay, so why don't we go ahead and create our paint object inside of our game view. So at the top, let's create a new paint object. Once again, we're going to make this one private. So why not do a private paint. Alt enter, save, great. And we're going to be working with the paint object here inside of draw. Now it's time for us to actually create our first game object, and that's going to be a star field. That is a field of stars that are going to blink in and out. We're only going to do one game object in this lesson, and that's because things are getting a little bit long right now, and I kind of want to space these out so no one gets particularly bored. For right now, we're going to create a new class called star field. So let's go ahead and do that. So over here, let's go to right-click, new Java class, bring it on over here and call this star field. The superclass is going to be our game object class, and that's pretty much it. Hit OK. It's going to give you some problems because you have not implemented the abstract methods. So why don't we do that? Alt insert, and let's go to implement, and it says all of these ones. So we go ahead and implement all of those, and everything's great. Perfect. So what is the star field actually going to do? Well, why don't I show you first before we dive into the code? All right. So here is our star field, and if I press play, what you'll notice is we're going to get these sort of twinkling in and out dots all over the place. Now this is a lot of information going on right now. I've got, hundreds upon hundreds of stars kind of going in and out. And, that's kind of impressive if you think about it. We're not even dealing with OpenGL at the moment, but you're able to push quite a lot of pixels anyway. So let's continue on. What we're going to deal with the star field is we're going to extend our game object. We're going to need a bunch of Vector2 points, an array of them. We're going to have the number of points we're dealing with. We're going to have a paint object in this case where we're going to set up all of our paint information. We are going to have our current alpha value, which is how bright that star is at that moment. We're going to have a twinkle speed value, and we're going to use that delta time to work with that. So the idea is that it'll twinkle at 20 units of color per second. And finally, there's a directional value. Here we can see everything that we need to deal with. We're going to create it. We're going to have a constructor. It's going to take in how many points we want. It's going to say how fast this thing should actually be working. We're going to then save those values here. We're going to create a new paint object and, of course, give it a value. In this case, since it's a star, usually that's going to be a white value, unless, of course, you're very perceptive and you notice that stars are, other colors except for green. And of course, we can do things like points, and we're going to grab random locations for every single point, iterate over them, and give each one a different location that's within the size of the screen. Hence why we made these objects here get screen and get screen height, because it's important for us to have in other locations. And then finally, the last thing we're going to do is implement our update, which is going to be our calculate alpha. Calculate alpha is how bright, if you want to think about it, but really it's how much blended it is with the black background. And in this case, we determined the direction. The direction is either positive or negative, if you want to think about it that way. That is, we're either making it brighter or we're making it dimmer. And we're going to figure this out by taking our current alpha value, the speed, and multiplying that by delta time and whatever direction we have. Direction either positive or negative. If it's negative, it's going to be reducing. If it's positive, it's going to be adding to it. All right? So let's go ahead and start implementing this. So we have our star field. Let's add our variables now. So let's do a protected. Why are they protected? Because you never know when you might want to extend the star field to do other things. So protected Vector2 points, and that's going to be an array of objects. Then we're going to do our protected int number of points. Then we're going to do our protected paint and our paint object in this case. And that should be protected, not protected. And Alt Enter to bring paint in here. Next up, we're going to do a protected float current alpha is equal to 0 because it's going to start off at the lowest value. And then protected float twinkle speed. We're just going to set that to 20.0f for the moment, but the user is going to specify that, or at least the coder will. And finally, let's do our protected int direction is equal to 1. Now we actually get to implement everything. First, we're going to want our constructor. So let's do that. Alt insert. Let's go ahead and do our constructor. And what we want to take in for our constructor are the number of points and the twinkle speed. So we have number of points and twinkle speed. Okay? Great. And we can base everything off those two particular attributes. So now we'll do paint is equal to a new paint object that will hold. We'll do paint.setColor. Now you could of course pass in your own color if you want to. I'm going to do a color.argb. color.ar.argb, and I want to do whatever our current alpha value is, which I'm going to cast to an integer, so current alpha. And I want 255 for white, 255, or that is RG and B. Okay, now I probably have too much going on here, right? I need to surround that with another parenthesis. There we are. So you can see red, green, blue, and of course our alpha value right there. Next up are our points. So let's create that array. So points is going to be equal to a new vector2 of size number of points, which we got right here. There we go. Hit enter, save. And now that we have that, let's do our random. So random is going to be equal to a new random variable or a new random. Alt enter to make sure that we have our includes. Now we are going to iterate over everything. So for int I is equal to 0, I is less than number of points, and then of course I plus plus. Now let's do points I. Now since we're only doing this once, I'm not worrying about saving that value out, the I value out, and reusing it over and over again for performance reasons. It's just not an issue because this is only going to happen once for the constructor, and we're only going to have one star field. Let's do random.nextInt. We want to pass in the game view .get screen width, and then we're going to, after that, do a random.nextInt, and we want to do game view.get screen height, and a semicolon. So now we're going to populate the entire thing with a bunch of points. So now our on update's really simple. Like I mentioned before, we're actually going to delegate this all to another function called calculate alpha. So let's just do calculate alpha, put that in there, and let's go ahead and actually create that. So we'll do a private void calculate alpha. That's not going to take anything in. It's going to take in the direction though. So if the direction is greater than 0, that is, it's positive, then we're incrementing things. Otherwise, we're decrementing things. That is, we're removing opacity from the object. So we're going to do a current alpha is going to be equal to our current alpha plus the twinkle speed times our game view dot delta time times our direction. Now we need to do a quick check, because if we exceed 255, we need to make sure that we flip back. So we'll do current alpha. If current alpha is less than 255, or excuse me, is greater than 255, then what we need to do is current alpha is going to be equal to 255, and direction times equals -1. That is, we're going to flip it. And actually, you know what? If current alpha is greater than or equal to 255, we're going to flip the direction regardless. Okay, so now we're going to do our else loop, which is pretty much the exact opposite of what we're dealing with. So I'm going to go ahead and copy this stuff. So let's just grab everything we did here, copy, and bring into here. And then what we're going to do now is current alpha is going to be equal to, once again, the current alpha plus the twinkle speed times the game delta time times the direction. The direction here is going to be negative instead, so it's going to be decrementing things. Now, instead, though, we're going to be checking to see whether or not we are less than or equal to 0. If we're less than or equal to 0, we're going to want to flip back around and start going back up. So if we're less than or equal to 0, let's make sure that we are 0, and we're going to multiply our direction again by a -1. So if our direction is already a negative value, by multiplying it by another negative value, it's going to be a positive value, and then we're going to start executing in this part of the loop instead. Now the last thing we need to do is implement our onDraw section for this entire thing. So let's go ahead and do a paint object. So we'll do paint.setColor, and the color we want to set this to be is color.argb, and that's going to be, once again, our int typecast, and we are then going to do a current alpha. After that, we're going to do 255 for white, 255 and 255. You can make those values anything you want, by the way. Then we're going to go ahead and now actually draw those points to the screen, which is going to require another for loop iterating over every single one. So let's do a for, and I is equal to 0, I is less than the number of points that we happen to have, and then I plus plus. Now we can do our canvas, which got passed in, dot draw point, and we are going to pass into that points I, because that's the current one we're on, dot x, and points I.y, followed by our paint object. And that's it. With that, we'll be able to actually create a star field. But of course, we need to create that star field inside of our game view object. So let's go back over here within our constructor, and let's see, where are we? Here we are inside of game view, and there's run. Where did we create our, oh, there we are. We have an array list right there. So let's get game objects right there. So let's do game objects.add. We need to add to that a game object, and we're going to do a new star field. A new star field. And we need to pass in those two values. So number of points, let's just say 100. That's too many. Let's do 100, and then the time value is going to be a little bit less. So we'll do 100, and then we'll do Control P, twinkle speed. How about 30 units? So it's kind of slow. And a semicolon at the end. And let's go ahead and run this on our emulator. So go ahead and hit run there, go and initialize it, and we'll see what we get. So go ahead, pixel. Just go ahead and rotate our canvas there. And let's see, it looks like we got an error. So let's find out where that is. So double click, and it's saying that we have an exception. We have an unexpected token. So let's delete that one and go ahead and try it again. So hopefully you can see all those different stars slowly coming into view, and then they're dipping back out of view. I know it's kind of hard to see because the stars are so small, but let's see if we can't increase that size a bit here, huh? There we go. Now, hopefully you can see all those different stars coming in. Now, all those stars are coming in and out at the same time. If you wanted to, you could actually make each one blink individually. However, you're going to need two arrays. You're going to need an array not only for each star, but you're also going to need an array over the direction for every single one in the value. So the idea is that each star is going to have, whether it's going positive or negative, and then each value is also going to have, well, its own particular star value. And you're going to need to iterate over each of those, update them individually, and make that happen. Of course, that's going to slow things down a little bit, but it's going to provide you with a much nicer result, which is what you see in this video right here. So it's up to you. I leave that as a challenge to you to go ahead and implement the code I just showed you to see that you can, in fact, create something that looks like this. All right. I think that's enough for this video. We're already getting on close to over 45 minutes. Lots of fun stuff coming up. This is probably the most interesting stuff about Android that I love. All right, everyone. I hope you had a good time. I hope you enjoyed it. And I'll see you then. So long, goodbye.